Hey guys, today we're gonna go through problems A through D in the Codeforces round 1087 Div 2 contests that happened yesterday. I was able to do A and B during the contest, but I upsolved up to C and D, and in my opinion, I should have been able to solve C, at least C or D during the contest. I was able to do A and B within the first 45 minutes, which was kind of slow. Um, in my opinion, but just being able to solve them should have gave me rating. But I attempted C and D. I had enough like wrong attempts to where it like brought my score down by like 200 penalty points or something, and I ended up losing rating this contest. But I should have been able to solve C or D. I feel like because I did my daily Codeforces every day video. That's already out. Y'all can watch that if y'all want. And I was able to do them, and I did C in an hour and 3 minutes, and D in like maybe less than an hour, like 45 minutes or something. In my opinion, D is actually easier than C. But I think what threw me off during this contest was C is what's called an interactive problem, and I've never worked with that before. I think that just completely threw off my game during this contest, but it's actually like not that difficult. Now, today I'm gonna be like just going through my solves for these problems, and yeah, y'all can follow along. Hopefully, y'all learn something. All right, let's start with problem A. It's a pretty simple question. Again, y'all can pause the video and read the entire question if y'all want. I'm just gonna summarize what they're trying to say. So basically, we get three numbers and an array of monsters to kill. So our three numbers that we get is the length of the array, your combat power, and the number of flip-flops you have. And there's this unique interaction to where if you throw a flip-flop at a monster, it becomes stronger by 1 point. And you want to maximize your possible combat score at the end of the, or just maximize your possible combat score. Your combat increases by the amount of, I guess, damage. I guess they call it aggression in this question. Your monster has. So, for example, if you look at the first test case, they output 12 just because you can't beat this monster, right? The monster is always stronger than you, so at the end you just output 12. But if we look at the second test case, we output 16. This is because we start off with 8. We can throw 3 flip-flops at the monster. The monster will get to 8, and you can still beat him. So then you add 8 to your current combat score, and that's what we output. So the idea for this problem is pretty straightforward. As you can see in the tags, it is a greedy problem. You basically want to use as many flip-flops as possible. So let's start out just by taking some input. T equals int input. And then for in range T, we take in 3 variables. nck equals map int input split, and an array a equals list map int input split. I was actually supposed to record this contest for y'all, but I forgot to press record during the day, so it's a little bit unfortunate. But okay, so now that we have this, we can kind of just iterate through the array, and we iterate through the array, and we just throw flip-flops at. We throw as many flip-flops as the monster as we can. So for I in range in, if AI is greater than our combat score, we break because we cannot beat the monster. Otherwise, this is the number of flip-flops we should use, and it's between K and C, or it's Ci, or it's C minus AI. So yeah, so either you run out of flip-flops to throw at the monster to so what we want to do basically is we want to say our combat score is this much C and our monster is this much, so this is AI. We want to throw flip-flops at this until you can make AI equal to C. However, we might not have this many flip-flops. We might only have this many flip-flops, right? So we either throw all of the flip-flops we have, or if we have more flip-flops, then we throw C minus AI flip-flops, which is this much. This much is K, if that was our max. And this is our leftover, which we'll use for other monsters. So that's what this does here. The minimum between K and C minus I. And then, of course, we have to decrement our flip-flops by the number we use and increase our combat by the strength of the monster currently plus the flip-flops we use. Now, we can just iterate through, and at the end we print the combat. And this should be the answer to this question. Should have gone pretty quick. I don't know why it took me so long during the contest to get this one, but yeah. I don't know. I was just not reading the question or something. Messed up once. But okay, yeah. So this is my in-contest solution. Just run it. It works. Moving on. Let's keep the input. But okay, question B. This question is another pretty simple question. In fact, if you realize a pattern through the test cases, you can just implement the pattern. That's kind of what I did, but there's a little bit of logic to it as well. What this question is asking is, so you want to find the maximum number of indices j such that j is greater than I. You're given an array. Array is linked in. You want to find the maximum for each index I. You want to find the maximum number of indices such that j is greater than I, and ai minus k absolute value is greater than aj minus k absolute value over all the integer values of k. So what does that mean? So like if you want to read the notes down, here they are. But basically you can choose any k and then you count, like you output how many like indices that holds through for this case, and you quickly realize that like since negative numbers are allowed, you quickly realize that it can, like, you have to realize k can be any number. So you can deal with a negative k, a positive k, and what really matters in this problem is the number of numbers greater than your number or the number of numbers less than your number. Because since k can be anything, you want to choose a k that maximizes, or you want to choose a k that, how do you explain it? That allows you to pick the greater of the two options. So this question is pretty simple. You can do this by brute force. Basically what you do is you count the, like for each index you output the max between the numbers greater than the number and the numbers less than the number. So in this case, start out with a 1, you have 4 numbers greater than and 0 numbers less than, so you would output 4. 2, you have 2 numbers greater and 1 equal, so you would output 2. And then for 93, two numbers less, so you output 2. Am I looking at the right case? 4, 2, 2. Yeah. And then for 84, you just have 1 less. You output 1. And 2, you have nothing, so you output 0. So we can do this by brute force, like I said earlier. And what we should do, actually, is we should sort the array. Sorting it makes it much easier for us to determine how many is less than or greater than our current number. And we need to take in an n equals int input. Like this. Alright? And then we just iterate through a for I in range a. We can track a greater variable and a lesser variable, and we'll implement these loops later. But then all we need to do is, okay, we also need to track a toPrint variable. toPrint.append max greater lesser, and then at the end we just need to print out star toPrint. Okay, so what we can do here, we can actually just do like the one line for loop expressions. I'm not too sure if I remember how to do it exactly, but what did I do during the contest? It's like I dot count, or it's like I for I don't really have to be fancy with it. I can just write the for loops, but I did it during the contest and it worked, but I low-key don't remember what I did. So for we start at, okay, for j in range, for I in range in, for j in range, we start from we start from I plus 1 to the end. Let's see, 2, 1, 2. Do I need to do n plus 1? 0, 1. It would do, if I start at 1, I would do 0, 1. If I start at 1, 2, 3, 4. Okay, yeah, I think this is, I don't need to do anything to this. And then if aj greater than I, greater plus equals 1, else lesser plus equals 1. Okay, and then yeah, I think this is it. So yeah, basically all we're doing is we're counting how many numbers are greater than our current number and how many numbers are less than our current number. If it's j, this is j. Okay, yeah. And we just output which one's greater. So if we look at my code, this was the what I did. It's a little bit cool. It's kind of hard to remember, but basically you increment by 1 for the same thing we did earlier, and then append it to toPrint and then print it out. Okay, problem C. So I was able to do A and B in, like I said, 45 minutes. Problem C is where everything went wrong. This was an interactive problem. So what does that mean? I still don't know what it means, but apparently it's like you query with print statements to Codeforces or an online judge, and it gives you like the outputs. So you have to input their outputs into your code before you like finally output an answer or something like that. And so for this question, I would kind of just talk about the like idea behind the problem, and for implementation, I'll just show you what I did. It's kind of long, but it's not really long. It's just like a lot of like you'll have stuff where you have to write out a question mark or exclamation, like some formatting stuff. So I'll still try to type it out, but it's not going to be what I'm focusing on for this question. But yeah, so what this question is basically saying is we are given an array. We do not know what this array has or like what this array looks like, but this array is length 2n, and n is given to us as an input, obviously. And this array is built up with numbers from 1 through n, and the rest of the numbers are filled with zeros. So 1 through n can be in any order in the array, and the empty spots are all filled in with zeros. Our job is to find or like output an index where a 0 exists. And we are only allowed to query 2 indices into Codeforce. We're basically, okay, we're allowed to query, and we're allowed to query 2 indices. The machine will either output a 0, which means the numbers at those 2 indices will not match, or a 1, which means they do match. Now, the important thing to realize is if they do match, then both of them are just going to be zeros, and we can output either or, right? And this is because there's only multiple zeros. There's no multiple 1s, 2s, because it's from 1 to n, and then zeros fill in all the empty places. So there can only be multiple zeros. All right, so the idea behind this question is, let me open a new paint, is it doesn't actually matter the length of our array, so I'm just going to make some random blanks. And what we can do is we can check like we can pair up each of the elements and check what they output. If at any time we output a 1, then we can stop the program and just output like our current index, I guess. Like what we can do is like start at 1 and then I minus 1 or something. So we can either output I or I minus 1. It does not matter. But you're like, okay, so what about these? Like, why do we never check these? And then like, what if it's like all zeros, right? Because we can have like cases where it's 01, 02, 03, 04, yada, yada, yada. So this is just step 1. And we should keep track that this takes in checks. We're only allowed to query n plus 1 times. So this alone takes n checks. Our n here is there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blanks. N equals 10, or n equals 5, because our length is 2n. and we've already queried n times. Oh no, right? But for now, let's not worry about our n plus 1 bound. Let's worry about how can we find the answer first. Let's find a way to find the answer. And yes, this runs into the two issues we said earlier, but if any of these happen to have a 1 output, we can already know our answer, right? So next thing we can look at is the only way this doesn't have an output we're looking for is if they're alternating. So like 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. Or like we might have like this case where it's like 1, 0, 0, 2, yada, yada, yada. Where they're still next to each other, but we can't check it because it would use too many checks. Like if we truly checked each one, it'd be like 2 n checks, and we can't do that. So now, what we're looking to do is how can we find the, or what can we check to like find our answer from here? And in this first case, let's just look at 0, 1, 0, 2. We can simply see that we can check 1 and 3. This will give us a 1, and since we get a 1, we can break and output our answer. But what if we have something like 1, 0, 2, 0? We check 1 and 3 still. Oh no, it outputs 1. So this basically forces us to know that A2 is a 0, so we can just output A2. And why is this the case? Because all the other cases are also outputting 0. So by process of elimination, this place has to have a 0. Now, again, this takes well, sorry, I was a little bit ahead of myself here. We don't know for sure yet, but we can check this. And if this gives us a 0, then this place has to have a 0. If this place gives us a 1, then that means both of these are zeros, and it just works. But yeah, but now if we look at that, that's n plus 2 operations, right? We have the n checks, and then this check, and this check. So we want to get rid of at least one operation to make this possible. So just to make this cleaner, let's clean this up. New, don't save. We have boom, 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 dot, dot, dot. We're checking these. And then we're checking these. And then we're checking these. And the question to ask is, which check can we remove? We only need to remove one. Now, so I guess the easiest way to find out which one to remove is just kind of trial and erroring these four. Or these four checks. This one, this one, this one, and this one, right? Sorry, that's a bit messy. But we know we always need to do these side checks, because if we don't do these side checks, we can just, like, this is our check number one. If we find one, we just return. If we don't do this, then there's no point in like ever checking these, right? So if y'all want to pause the video here and just try to see if y'all can figure out which check to remove, that would probably be a good idea. But I'm just gonna jump straight to explaining the answer. So The check we don't need is actually this one here. And this is because these three spots are kind of arbitrary. Well, not arbitrary, but like you don't really know what's there at any time unless one of these three checks. So this 1-3 check, 1-4 check, and 3-4 check. Unless one of these three checks returns a 1, then you don't really know what's there. You know that all three of these numbers are not the same, which means it could have a 0, it could have a like 1, 2, 3, etc., etc., etc. So what that means is, okay, let's say one of these returns a 1. Then we automatically know what to output, right? There's either of these indexes. If all three of these output a 0, that means all three of these numbers are different. And since all of these numbers have outputted 0, that means each of these contains at least a number and a 0. Or it could be two numbers. But what that means is we kind of run out of numbers that these three slots or these four slots can be, right? In fact, the distinct numbers we can have here are, so say worst case we alternate every number and our n is 3. The amount of distinct numbers we can have in the first 4 are 3, which is 0, 1, and 2, right? And this is assuming that this check still happens and we get 0 for every case. And in this case, we get a 0 here, right? So there's at least 2 zeros in this block and 2 random numbers. It could be more zeros, but yeah, more zeros is better for us. More zeros means like one of these checks will pass unless it's like 0, 0, you know, and that doesn't mess with anything. But so if all three of these zeros happen, one of these three areas is a 0, and then the other two are the other two leftover numbers. That means this spot is guaranteed to be a 0. And that is our kind of our solution here. We basically just, to summarize, number one, check starting from this point. We don't actually need this check at all. And check every pair. Like pair these numbers up and check every one. See if there's a 0. Or see if there's a 1. If there's a 1, stop, return I. If there's not, check 1, 3. If there's a 1, stop, return I. Else, check 1, 4. If there's not, then we return 2. And if there is, obviously we just return I. So that is the solution to this problem. So to code that up, and I'll just bring this question on the side and kind of walk us through, because again, I have these weird formatting lines. But to start, we can track it to print variable. Set it to -1 just because in the question it says if you made an invalid query or exceed the limit, print -1. This doesn't actually ever happen, but it's just good practice to keep track of it. Oops, there we go. And then for I in range, we start at 2. So if we take a look at here, we start at 2. This is 0, 1, 2. In Codeforces, it's 1, 2, 3. But for the sake of arrays right now, we're starting at 2. We're going to n plus 1. So from 2 to n plus 1. And then print. So for these interactive questions, querying is actually just a print statement, which is kind of strange. And I didn't know this during the contest. Like I couldn't figure this out for the love of God. But so what it wants us to do is every time we want to query to the problem, we should print a question mark and the two indices we are querying. So in this case, we are querying 2 times I minus 1. So, and I'll explain why we're doing this 2 times thing in a second. So, yeah, we're doing this 2 times thing because of our limit in, right? We're basically just, what I could have also did is like added a, like this, but it's the same thing. So, oh, hello. This is just letting us like group these, and in this case, this would be 2i, and then this would be 2i minus 1. All right, and then this will query, and then it'll print out some output. Output equals, and we should take in the output as input. So this is also pretty strange, just because it wasn't, like, we're not told input, right? Like the other questions, we just kind of had to expect it as, like, I don't know, it's weird. I don't like these types of questions at all. But okay, so if output is a 1, we break here. We set to print equal to I, and we break. And then else, so what this entire loop is doing right now is it's doing these checks starting from here all the way to the end. And if there's a 1, we just end the problem and output our answer, and end the problem. This else block here is what happens if we are not able to find a 1. And what we do is we check 1, 3. So we query again and take output. This time we check 1 and 3. And if we get a 1, print 1. Else, we query again, and we query 1, 4. If we get a 1, so let's copy all this. We can print 1. We don't need the break here anymore. Else to print is equal to 2. So if we ever get a 1, we just print out 1. If we don't, we print 2. And then we should just be able to print at the very end. And where's my C? Oh, I dragged it out, that's right. Let's put this back here. Implementation actually wasn't too hard. I probably didn't need to drag it out. But yeah, as you can see, I did pretty much the same thing. Query, take output. I'll clean it up a little bit, like this. And oh yeah, there we go. I did forget something. When printing out, they wanted to print out the exclamation mark and to print. And this is another thing to remember to do. When you're printing, you have to flush equals true. This is kind of explained here, not really, but for interactive problems, you need to flush your print statements. And I didn't know that during the contest either. So I was cooked this contest, but there you go. And this should run. Testing this is kind of weird. You have to run it in terminal, and let's just look at a case. Maybe we we do 0, 1, 0, 2, we should, so what we're doing is, let's do 0, 1, 0, 2, 0, 3. What we're doing first is we're comparing these, and then we're comparing these and these. So it should be, this is 1, 2, 3, 4. And then at the end, it should end on 3, this 3 check. All right, so testing 1, and then we need to tell it its length, which is 3. And so it checks 3, 4, these two. We need to tell it 0, 5, 6, 0, and then 1, 3 is a 1, so it just outputs 1. But yeah, this one was a pretty difficult challenge intuition-wise, in my opinion, and on top of all the interactive problem BS. But yeah, it wasn't a super difficult problem. Like you can see when I was doing it during contest, like what the fuck is happening with this problem, right? Like, but whatever. All right, on to D. D is actually, in my opinion, much easier than C. Just because for this problem, there's not much going on. There's not like a trick to this problem. You kind of just do what it's asking you to do, and we can like figure out this little like formula or cheat sheet on how it's supposed to behave at each like stage. So what we need is, oh, I guess I should read the problem first. Basically, you're given a number of R's, and you're given the number of R's, G's, and B's you have, and you want to make the longest string possible such that two adjacent characters are not the same, and two of the same characters are not separated by two different characters. What does that mean? That means like, do they explain anywhere? Okay, yeah, basically like GG can't ever happen because they are adjacent, but also something like GXXG can't happen because there's two characters in between them, right? So the idea for this problem is you're tracking the counts RGB, right? And then you need to track your previous values. You only care about the last 3 previous values. So I'm just gonna do this. And this is like previous 1, previous 2, previous 3. And then what you do is step 1, disable count zeros. So if RG and B are ever equal to 0, just disable them. You're not allowed to use them for your next letter. Also, disable prev 0 and prev 2. Right? This is because prev 0 means your previous one is the same as your current, so you're not allowed to ever have that happen. And prev 2 because the 2 in between thing that I was talking about earlier. And then at this stage, pick max of non-disabled. Now there is a kind of edge case to this. Like, if two numbers are the same, so let's say we're picking the max, but we get r equals 2 and g equals 2. We check if the previous, or we check if either of these were used one turn ago. So in this case, it's prev 1. So tie break one. And we need to do this because we can run into cases like this. This case here, 222, where we like just greedily use the max, and let's say 222 we do like RGB, and then we can't use R because it's disabled, so we do G, and then it greedily uses R, and then because R is the top one, it's tied with B, right? And then oh no, we can't use B anymore because there's two in between. So we break it with the tiebreaker of prev 1. Prev 1 is B in this case, so we use B, and then we go back and use R, and that's our longest string. So this is step 1. I guess this is step 2. I think this is actually like the whole thing. Yeah, that looks right to me. And to implement, sorry, let me get this out of here. Test 2. We need to input RGB equals, what can I steal here? And okay, so what I did was my implementation was actually kind of sloppy. I had a state variable, states equals this. I also had a counter variable, which is also a dictionary, and it was like, okay, R G B oh my god, B. And then let me copy this, paste this here. True, true, true. And then, so counter is tracking how many of each we have. This will be incremented down as we use them, right? States is which ones are like enabled and disabled. And what we do is first we check if counter R is equal to 0, we disable the state. And we do this for all three cases. R, G, oh, what am I doing? And then B. And then we loop through while state R. Oh my god, this is so annoying. And or state G or state B. So as long as one of these states are possible, we do this, we track a usable variable, BLE. These are the keys of the states we are allowed to use. And to do this, we do key for key value in states dot key or dot items, state dot items let me think. If value equals true, and then to use is equals max usable lambda states k, where k is equal to I don't remember. What did I do? It was prev1. That's what I'm forgetting. I also need a previous array that tracks the previous values. Right. Let me just take a quick glance. Boom. Let me just copy this real quick. Oh. Oh. Hello? There we go. So yeah, I guess that's what I forgot. Key equals, and then set our lambda, and then counter k, where k is equals previous. So basically, what this is doing is, like I said earlier, take the maximum, and have the tiebreaker be prev1, and then what we need to do here is prev. We need to set the prevs. Prev0 equals. Okay, so what I also need to do here is I need to reset all the states to true. And then prev0 equals to use prev1 the ordering does matter here. Let me just copy and paste this. It's prev2, prev1, prev1 here, and prev0 here. So prev2 equals the previous prev1, and then prev1 equals the previous prev0, and then prev0 equals 2u's, and then we should disable states prev0 equals false, enable states prev1 and disable states prev2. And then we need to do all this again. Check our zeros and then set them to false. And then at the end, we print. Oh, I forgot to track a toPrint variable. ToPrint equals should be an array. And then just do like toPrint dot append to use. And then I also forgot to decrement it should be states, or it should be counter to use minus equals 1, and then print join toPrint. Okay, I think that's it. Now let's compare it to what I wrote. There's our toPrint, our counter prev in states, set it to false if it's equal to 0, and then check while one of these are true, one of the states are true. Look for our can use, key for key value in states if value is true. Yeah, it's pretty much the same. And then to use equals max of the keys in can use, and then use prev as a tiebreaker, or the max of the values of the keys in can use. As you can see here, key is k, and then plugging it into counter. Yeah, and then append to use counter minus equals 1, counter to use minus equals 1, reset the states, increment the prevs, set false true false, and then set if 0 equals false, and then print and submit. Or I did not mean to press submit, but why did it even let me submit? I've already submitted this before. Usually it says same code or something like that, but I guess we can wait for it. I don't really mind. I didn't change anything, right? Yeah, kind of weird. I don't know. I guess I'll do my outro now. If y'all enjoyed this video, be sure to like and subscribe. If this video helped you, comment down below, I guess. If y'all have questions, ask away. I'll respond to all of them. And yeah, we're just waiting for this to run. And probably delete this test file. See, accepted. Alright. If y'all enjoyed this video, like and subscribe. I'll see y'all guys next time. Bye.